Oh my goodness, look at all these identities. So if I look over at the formula sheet, this is the moment in the course that suddenly you are flooded with a whole pile of formulas in the case of identity. So all these ones over here I've reprinted. So I just want to allay your fears a little bit. You do not have to memorize any of these. This is why they're on the formula sheet. In fact, there's a few of them that I have memorized because I've used them a bunch, but quite often I do the same as you and check the formula sheet. So first of all, just the terms, the sum. So you'll notice that here are the pluses. So if you have two different angles, now notice we're using the alpha symbol and the beta symbol. We've thrown out theta just for the moment, but you can use any symbol you want. So if I'm going to say I need to add two angles together, the sine of two angles added together, there is an identity for that, and it looks kind of complicated. And so those are the sum, and then here are the difference ones. So that refers to those ones over here. And then if I go to the bottom, the double identity, what I'm talking about, or double angle identity, is the fact that the angle is doubled. So I want to talk, before we get right into it, I'm going to just think about what it means to have a double angle identity. So let's consider maybe an angle of, if sine of an angle is equal to root 3 over 2. So maybe like this could be the spot there. So what do we mean by that angle? So that angle would mean, and I'm going to take you right back to our earlier days. If we started with, this is your initial arm, and you're rotating that amount. In radians, we are rotating, what is that? Pi over 3, right? So the sine of pi over 3 is equal to root 3 over 2. What about if I double the angle? What would your instinct be if I said, hey, what's the sine of twice the angle? Some people might think, maybe, I'm going to put a question mark over there, might think that it's twice root 3 over 2, that's the way that the function sine works. I'm going to switch to green because it might help. So if I go twice the rotation, so then I'm going to, instead of ending at pi over 3, I'm going to end up at 2 pi over 3, which is over there. So twice, here I'm going to erase that because I want to show the rotation. So the rotation would be from here to there. So that's now 2 pi over 3. And in fact, this is an interesting one. The sine of 2 pi over 3 in this case is exactly the same as the sine of pi over 3. So in fact, in this case, it would be exactly the same. It would still be root 3 over 2. And that's why I said in this case. So it actually gets pretty complicated. If you pick some angle and then you double it, sometimes you, instead of having a positive value, you would get a negative value. Sometimes it would double, sometimes it would stay the same, all these types of things. So I just want to make sure that when you're looking at double identities, you're realizing that you're not doubling the answer, you're doubling the angle before you're putting it into the function sine. Hopefully that makes sense for you. Let's go on to the next page, and I've got some examples here. So simplify the following expressions and give the exact value. So here's the part where if you have your formula sheet in another page, it's kind of helpful so you don't have to flip it back and forth all the time. But I'm going to have to flip back a little bit. So I'm going to look at this. It's got cos plus sine, sine. So I'm going to look for which one has cos plus sine, sine. Here, I'm going to erase some of our other business. It seems to me that the one that I want, here, I'll erase all that other stuff. The one that I want is this one, cos plus sine, sine. And notice it's cos alpha times cos beta, and what that is equal to is the cos of alpha minus beta. So if I'm looking at here, my answer is going to end up being, I'm just thinking about here, cos alpha minus beta. And this is alpha. I'm trying to write alpha. There's alpha and there's beta. So this is going to be equal to the cos of pi over 3 minus pi over 12. And I'm putting parentheses in there because the angle is pi over 3 minus pi over 12. Okay, a bit of fraction work here. So in order to subtract those two fractions, they have to be the same denominator. And so I think it's going to have to be pi over 12s. So I'm going to say this is equal to the cos of 4 pi over 12. That's right, because I had to multiply 3 times 4 minus pi over 12. So that's going to be equal to the cos of 3 pi over 12, which is equal to the cos of pi over 4. And I think we can figure out what that is. Pi over 4, that's over there. That's our good old root 2 over 2. So there's our answer. Okay, the second one, cos squared 47 degrees plus sine squared of 47 degrees. What? I didn't see any 47 degrees. Where is that one? Well, I'm being a little tricky because it's actually from, if I go all the way back to the formula sheet, it's this one, isn't it? It's our very first one, identity. Sine squared plus cos squared equals 1. So if I go over here, let me see again. I'd switch the orders around as well. So this reminds me of like sine squared theta plus cos squared theta equals 1. So I've just rearranged it, and it doesn't matter what the angle is. It's always going to be equal to 1. So my answer for that one equals 1. Cool. All right. 1 minus 2 sine squared of some angle. So I'm going to look over here. 1 minus 2, oh, here it is, right there. So 1 minus 2 sine squared of some angle is equal to cos of twice that angle. Okay, so that's going to be equal to the cos of, what's twice of pi over 8? I could say 2 pi over 8. Really, that's the same thing as cos of pi over 4. And it's one of those pi over 4 ones. Again, it's going to be root 2 over 2. Okay, so why don't you try these 3 your turns and then give it a shot. And then I'll come back and I'll show you what I got. Thanks.